Hi viewers and group members. In the last video we have discussed the concept of sets and the basic definition of sets. Today let us explore some more knowledge in the concept of sets. Before going to the today topic, let us recollect what we have learnt. What is the definition of set, children? Set is a well-defined collection of objects. Well-defined means all the objects in the set should have common property, and it should be determined whether the given object is in the collection or not. This is the condition for well defined. Okay, let us see some stars in the sky. Is it a set or not? Say, children. Yes, it is not a set because some stars in the sky is a just group. It is not a well defined, so it is not a set. Why it is not a well defined? Suppose I show some star. The star may be in that group which we said some stars in the sky. So we are not determining whether that star is in this group or not. So some stars in the sky is not a set, just it is a group. Let us see some more example. A group of tall persons. A group of tall persons. Is it a set or just a collection? Yes, very good. It is a group because exactly it is not a well defined. A group of tall persons is not a well defined. Why? Because what is the height taken into consideration in defining the tall persons? So it is not clearly defined. So it is just collection. It is not a set. Suppose I say a person with 80 centimeters is a tall person or not in your view? A person with 80 centimeter may not be belongs to the group which we said or not. Why? The particular definition for the tall person is not given. So we are not determining a person with some height is belongs to that group or not. So a group of tall persons is not a set. Now let us see one more example. A group of tall persons whose height is more than 160 centimeters. Think, is it a set or just a group? Yes, very good, it is a set. Why it is a set? Exactly, it is a well-defined collection. How you say it is a well-defined collection? Here, the particular height for considering a person whether he is a tall or not. So it is well defined. So see, I say one person with 100 centimeter. Is this person or this object belongs to the group you said? Yes, it does not belongs to the group because in our group tall persons whose height is more than 160 centimeters. So we are saying the person is not belongs to the group. So we can determine whether a person with particular height belongs to the said group or not. So it is a well defined and it is a set. Natural numbers, group of natural numbers. Is it a set? Exactly, it is a set. What are the natural numbers? 1, 2, 3, 4, 5. We can determine whether 0 belongs to it or not. We can determine -3 belongs to it or not. We can say 100 belongs to the natural numbers or not. So natural numbers is clearly set. And all whole numbers, all integers, all rational numbers, these are all sets. See one more example for sets. Even numbers less than 20. Is it a set? Let us try to write what are the even numbers which are less than 20. 2, 4, 6, 8, 10, 12, 14, 16, 18. These are the even numbers which are less than 20. It is a well defined. Why? Easily we can determine whether 19 is in that group or not. We can say 16 is in that group or not. We can say 1 is in that group or not. So it is also a well-defined collection. So group of even numbers less than 20 is exactly a set. Let us see another example for sets. First 6 multiples of 5. Is it a set? Let us try to write what are the first 6 multiples of 5. Children, try to write the first 6 multiples of 5. Okay, let us see. 5, 10, 15, 20, 25, 30. These 6 numbers are the first 6 multiples of 5. Other than these 6 numbers are not the first 6 multiples of 5. So we can clearly determine whether the given number is in this collection or not. So it is well defined and it is a set. Suppose you say 0. 0 is the multiple of 5? No. Suppose you say 29. Is 29 is the first 6 multiples of 5? No. Suppose you say 35. Is it the first 6 multiples of 5? 35 may be the multiple of 5, but it is not in the group of first 6 multiples of 5. Clearly we are determining the given numbers so far are not in that collection. Suppose you say 10. 10 is exactly in the group of first 6 multiples of 5. So first 6 multiples of 5 is a set because it is well defined. Let us go for one more example. Factors of 12. What are the factors of 12? What is the meaning of factor? Factor means the number which divides the given number exactly is called the factor. Now we have to write the factors of 12. That means we have to write the numbers which divides 12 exactly. Children, can you write the numbers which divides 12 exactly? See, 1 is the factor of 12 because 1 divides 12. 1 12 is 12. And again 2, 2 6 is 12. The remainder will be 0. So 2 divides 12 exactly. 2 is the factor. And again 3 4 is 12. 3 is the factor. 4 3 is 12. 4 is the factor. 6 2 is 12. 6 is the factor. 12 1 is 12. 12 is the factor of 12. These 6 are the factors of 12. Say, what are the factors of 12? 1, 2, 3, 4, 6, 12. These 6 numbers are the factors of 12. Suppose you say the number other than these 6 numbers is not in this group. Suppose you say 18. 18 is the factor of 12? No. Suppose you say 6. 6 is the factor of 12. So we are exactly determining given number is in that group or not. So factors of 12 is exactly a set. Let us go for one more example. What are the solutions of a quadratic equation x square minus 5x plus 6 is equal to 0? Solutions of a quadratic equation x square minus 5x plus 6 is equal to 0. What are the solutions of this quadratic equation? Quadratic equation has two solutions. That means there are two values satisfy x square minus 5x plus 6 is equal to 0. When we solve this quadratic equation, we get two values for x, 2, 3. See, 2 satisfies x square minus 5x plus 6 is equal to 0. When you substitute in place of x, it is satisfied. When you substitute 3 is also in place of x, this also satisfies x square minus 5x plus 6 is equal to 0. So 2 and 3 are the solutions of x square minus 5x plus 6 is equal to 0. So this is a set. Why? Other than 2 and 3. Other than 2 and 3 are not the solutions of a quadratic equation x square minus 5x plus 6 is equal to 0. So we are clearly determining a given number is in that group or not. So solutions of a quadratic equation x square minus 5x plus 6 is equal to 0 is a set because it is well defined. Let us see another example. The lines which are parallel to x-axis. It is clearly a set. And see, the lines which are perpendicular to x-axis. Let us see one example for geometry. Quadrilaterals in which each angle is 90 degrees. Is it a set? If it is a set, what are the elements in it? Let us see. Quadrilateral in which each angle is 90 degrees. You can recall in which quadrilaterals each angle is 90 degrees. Okay, good. Square, rectangle. These two are the objects. These two are the objects in the collection of quadrilaterals in which each angle is 90 degrees. So it is well defined. If you say another quadrilateral, we say it is not in this collection. So we are clearly determining whether the given figure polygon is in this group or not. So quadrilaterals in which each angle is 90 degree is clearly a set. Okay, so far we have seen so many examples for sets, which are sets, which are not sets clearly. I think you have got a clear idea about the concept of sets and the examples of sets. Okay, see children, how we write the sets. How we write the sets. Sets are denoted by uppercase English alphabet. Uppercase English alphabet. What are those? A, B, C, D, so on up to Z. These uppercase English alphabets are used to denote a set. And see, we have a symbol for sets. It is a particular bracket. A particular bracket is used to write the objects in the set. The particular symbol name is curly bracket or flower bracket. Funnily, we say it as misala bracket. We write the objects in the set in this curly bracket. By closing the curly bracket, we write all the objects of the set. Suppose n is the set of natural numbers. N is the uppercase English alphabet. we can write n is equal, we start curly bracket 1, comma 2, comma 3, comma 4, comma dash dash, and we close the curly bracket. This is the representation of set exactly. Suppose, write the set of vowels in English alphabet. What are the vowels in English alphabet? A, E, I, O, U. We denote the sets by uppercase letters. Suppose we take the name of the set of vowels in English alphabet is V. Now we can write capital V is equal, we start curly bracket, we write A, comma E, comma I, comma O, comma U, and we close the curly bracket. This is the way we represent the sets. We write the sets like this. Some more example for that. What are the factors of 10? We can use the set symbol and try to write the factors of 10. If we denote the factors of 10 set by capital F, now we can write F is equal to, start the curly bracket, try to write the factors of 10. 1 is the factor of 10, so write 1, comma. 2 is the factor of 10, write 2. 5 is the factor of 10, write 5, comma. 10 is also factor of 10, 10. And now close the curly bracket. In this way, we write the sets. And the objects in the set are naturally denoted by lowercase English alphabet. Sometimes objects in the set may be letters, numbers, words, whatever the objects may be. The objects in the set are called elements. What are the elements? All the objects in the set are called elements. Suppose we wrote the set of vowels V is equal A, E, I, O, U. These A, E, I, O, U are the objects in the vowels of English alphabet. These objects are called the elements of the set. Whatever the objects in the set are called elements of the sets. Okay, now one more condition is there. There is no condition of order of writing the objects in the set, writing the elements in the set. Whatever the order, suppose somebody writes set of vowels in English alphabet V is equal A, E, I, O, U. You may write U, O, I, A, E. This is immaterial. Order of writing the elements in the set is immaterial. Suppose 1, 2, 3 are the elements of a set. You can write 1, 2, 3, 2, 1, 3, 3, 2, 1. Whatever you write, the order of writing the elements in the set is immaterial. We cannot take it into consideration while writing a set. Okay, we have seen how to write the sets by using the symbol. What is the symbol for sets? Curly bracket is the symbol for sets. Now we discuss some more in the topic of sets. Now you see there are two particular symbols. Let us try to know. The first symbol is belongs. You can see the symbol belongs on the screen. And One more symbol does not belongs. How to write the symbol does not belongs? You can see on the screen. See children, what are the usage of these two symbols? Belongs and does not belongs. Where we use, what are the uses of these symbols? We use the belong symbol when a particular element is in the set. We use the element belongs to the set. A particular element is not in the set. We use the symbol does not belongs to represent those situations. Suppose you see the factors of 6. Now we write the set of factors of 6. Suppose you represent or you use the symbol capital F for the set. Now we write F is equal to, start curly bracket and write the factors of 6. F is equal to 1, 2, 3 and 6. These are the factors of 6. 1, 2, 3, 6. These are the elements in the set of factors of 6. 1 is the element in the set F. 2 is the element in the set F. So we can say 1 and 2 belongs to F. And we write the same thing as shown in the screen. First we write 1, take the dash and the name of the set F. What symbol do you use in between 1 and name of the set F? If 1 is the element of the set F, you can use the symbol belongs in the blank. Whether 1 is in the set of F, very good, yes, 1 is the factor of 6 and 1 is the element of set F. So we use the symbol belongs. So you see on the screen 1 dash capital F. In the blank we fill with the symbol belongs. 1 belongs F. We write like this. Suppose 10 dash F. If 10 belongs to the set F or not. 10 does not belongs. 10 is not the element of set F. 10 is not the factor of 6 and 10 is not the element of F. So we use does not belong symbol here. You see on the screen 10 dash capital F. If 10 belongs to the set F, we write the symbol belongs. If 10 is not the element of the set F, we write the symbol does not belongs. Which symbol we can write in that, children? Very good, does not belongs. So we write by using the symbol 10 does not belongs to F. These are the particular two symbols to write whether the given element is in the given set or not. We see some more examples to understand the concept of belongs and does not belongs. Suppose V, capital V, is a set of vowels in English alphabet. We can write V is equal to A, E, I, O, U in the curly bracket. Okay children, Now I try to ask some questions on this A dash V. What symbol do you write in between them? Belongs symbol or does not belongs to symbol? A dash V. If A is the element of set V, we write belong symbol. If A is not the element of set V, we use the symbol does not belongs. Say children, A dash V. Which symbol do you write in the blank? Very good, belongs symbol. A belongs V. Now, some more questions are on the screen. Try to answer them. Z dash V. What you fill in the blank belongs or does not belong symbol. Very good. Does not belongs. P dash V. What symbol do you write in the blank? Does not. Very good. Why? Very good. The particular P is not the vowel of in English alphabet. So P does not belong to V. I dash V. What you write in the blank? Belongs symbol. Very good. I is the element of V. So I belongs V. B dash V. What do you write? Belongs symbol or does not belong symbol? Does not belongs because say children, B is not the element of V. And C, U dash V. What symbol do you write in the blank? Belongs. Nice. Because U is the element of the set V. And R dash V. What do you write? Very good. And E dash V. What do you write? Very nice. These examples are useful to you understand the usage of symbols belongs and does not belongs.